We talk about variables in every programming language. PLSQL is no exception. Variables are storage locations to store data that is processed in a given PLSQL block. These variables serve as placeholders in the machine's memory. You should declare these variables in the declare section of the PLSQL block before using them in the code. Variables can hold different types of data such as numbers, characters, character strings, date, time, and so on. Let us now see the usage of variables in PLSQL. Consider a scenario where you are required to update the salary of an employee with employee ID 100. The update will be an increment by $100. To perform this operation, you should first retrieve the salary of the employee into a variable emp_sal. Select salary into v_sal from employees where employee_id equals 100. Then you run an update command on it. Update employees set salary equals v_sal plus 100, where employee_id equals 100. Each variable is associated with a name, which is also termed an identifier. When you declare a variable, you specify the identifier name and the type of data that the variable will have during the execution of the PLSQL block. You learn about the data types that are supported in PLSQL later in this lesson. Declare and initialize them in the declaration section. You can declare variables in the declare section of any PLSQL block, subprogram, or package. Declarations allocate storage space for a value, specify its data type, and name the storage location so that you can reference it. Declarations can also assign an initial value and impose the not null constraint on the variable. You must declare a variable before referencing it in other statements, including other declarative statements. Use variables and assign new values to them in the executable section. In the executable section, the existing value of the variable can be replaced with a new value. Pass them as parameters to PLSQL subprograms. Subprograms can take parameters. You can pass variables as parameters to subprograms. Use them to hold the output of a PLSQL subprogram. Variables can be used to hold the value that is returned by a function. Identifier is the name of the variable. Data type is a scalar, composite, reference, or lob data type. This course covers only scalar, composite, and lob data types. Constant constrains the variable so that its value cannot change. Constants must be initialized. Not null constrains the variable so that it contains a value. Not null variables must be initialized. EXPR is any PLSQL expression that can be a literal expression, another variable, or an expression involving operators and functions. Default is the predefined default value that every data type has. You can initialize the variable of a data type to a default value by using default during declaration. Initializing is assigning an initial value to the variable. In the slide, we demonstrate the difference between initializing and declaring. 1. In the first block, the v_myname variable is declared but not initialized. A value John is assigned to the variable in the executable section. String literals must be enclosed in single quotation marks while initializing. Variables are assigned values with the assignment operator, equals. The put_line procedure is invoked by passing the v_myname variable. The value of the variable is concatenated with the string, my name is. In the second block, the v_myname variable is declared and initialized in the declare section. v_myname holds the value John after initialization. This value is manipulated in the executable section of the block. The output of this anonymous block is. You can initialize the variables in a PLSQL block through a select statement by using the int clause. The variables following the int clause should be declared in the declare section. Select_list specifies a list of at least one column, can include SQL expressions, row functions, or group functions. Variable_name is the scalar variable that holds the retrieved value. Record_name is the SQL record that holds the retrieved values table specifies the database table name condition is composed of column names, expressions, constants, and comparison operators, including PL/SQL variables and constants. Each PL/SQL variable has a data type, which specifies a storage format, constraints, and a valid range of values. PL/SQL supports several data type categories, including scalar, reference, large object, LOB, and composite. The variable type is defined by the data type it is declared for. There are 4 categories of data types. Scalar data types. Scalar data types hold a single value. The value depends on the data type of the variable. For example, varchar2 is a scalar data type. The v_myname variable in the example in the section titled Declaring and Initializing PL/SQL Variables in this lesson is of type varchar2. Therefore, v_myname can hold a string value. Reference data types. Reference data types hold values, called pointers, which point to a storage location. LOB data types. LOB data types hold values, called locators, which specify the location of large objects, such as graphic images, that are stored outside the table. Composite data types. Composite data types are available by using PL/SQL collection and record variables. PL/SQL collections and records contain internal elements that you can treat as individual variables. The example variable declarations shown in the slide are defined as follows: v_emp_job, variable to store an employee job title. The string is a variable length string with an upper limit of 9 characters. v_count_loop, variable to count the iterations of a loop, initialized to 0. v_department_total_sal, variable to accumulate the total salary for a department, initialized to 0. The numeric value can accommodate decimal values with a precision of 2 digits. v_order_date, variable to store the ship date of an order, initialized to 1 week from today. c_tax_rate, constant variable for the tax rate, which never changes throughout the PL/SQL block, set to 8.25. v_valid, flag to indicate whether a piece of data is valid or invalid, initialized to true. Some guidelines to follow when you declare PL/SQL variables are as follows. Follow consistent naming conventions. For example, you might use name to represent a variable and c_name to represent a constant. Similarly, to name a variable, you can use v_fname. The key is to apply your naming convention consistently for easier identification. Use meaningful and appropriate identifiers for variables. For example, consider using salary and sal_ with commission instead of salary1 and salary2, where we understand the semantics of the column name according to the application context. If you use the not null constraint, you must assign a value when you declare the variable. In constant declarations, the constant keyword must precede the data type name. The following declaration names a constant of the number type and assigns the value of 50,000 to the constant. A constant must be initialized in its declaration, otherwise, you get a compilation error. After initializing a constant, you cannot change its value. Initialize the variable to an expression with the assignment operator, equals, or with the default reserved word. If you do not assign an initial value, the new variable contains null by default until you assign a value. To assign or reassign a value to a variable, you write a PL/SQL assignment statement. However, it is a good programming practice to initialize all variables. 2 objects can have the same name only if they are defined in different blocks. Where they coexist, you can qualify them with labels and use them. Avoid using column names as identifiers. If PL/SQL variables occur in SQL statements and have the same name as a column, the Oracle server assumes that it is the column that is being referenced. Although the code example in the slide works, code that is written using the same name for a database table and a variable is not easy to read or maintain. The table in the slide displays some examples of the naming conventions for the PL/SQL structures that are used in this course. The data types that are prefixed with N are national character set data types, which means that they are used to store Unicode character data. Char maximum_length base type for fixed length character data up to 32,767 bytes. If you do not specify a maximum length, the default length is set to 1 byte. NCHAR is a national character set variant of char. VARCHAR2 maximum_length base type for variable length character data up to 32,767 bytes. There is no default size for VARCHAR2 variables and constants. However, the database will raise a compiler error if the size of the string is not specified. CLOB, used to store a variable length string that can store data up to 128 terabytes. You can use a CLOB data type if you expect the character string length to be greater than 32,767 bytes. If your string contains an apostrophe, identical to a single quotation mark, you must double the quotation mark, as in the following example, v_event varchar2, 15, equals, father, s-day. The first quotation mark acts as the escape character. This makes your string complicated, especially if you have SQL statements as a string. The slide shows how to use the Q notation to specify delimiters. You can specify any character that is not present in the string as a delimiter. The example uses and as delimiters. Consider the following example. v_event equals Q, Father's Day. You can compare this with the first example on this page. You start the string with Q if you want to use a delimiter. The character following the notation is the delimiter used. Enter your string after specifying the delimiter, close the delimiter, and close the notation with a single quotation mark. Number, precision, scale. Number having precision P and scale S. The precision P can range from 1 through 38. The scale S can range from -84 through 127. Integer. Integer data type, which conforms to the integer representation of your underlying hardware. It is also referred as binary_integer, and can accommodate integers in the range -2,147,483,647 through 2,147,483,647. Simple_integer, numeric data type, which results in shorter execution time for natively compiled code. Simple_integer and integer differ in overflow semantics. Integer provides better performance according to the underlying hardware architecture. Declare a variable as a simple_integer if you know that the value is never going to be null and the variable does not need overflow checking. Binary_integer is used to store singed integers. Binary_float, floating point number in IEEE 754 format. It requires 5 bytes to store a value. Binary_double, floating point number in IEEE 754 format. It requires 9 bytes to store a value. Binary data types are useful to improve the performance of computation-intensive operations. Boolean, base type that stores one of the 3 possible values used for logical calculations, true, false, or null. Date, this is the base type for dates and times. Date values include the time of day in seconds since midnight. The range for dates is between 4712 BC and AD 9999. Timestamp. The timestamp data type, which extends the date data type, stores the year, month, day, hour, minute, second, and fraction of second. The syntax is timestamp, precision, where the optional parameter precision specifies the number of digits in the fractional part of the seconds field. To specify the precision, you must use an integer in the range 0 to 9. The default is 6. Timestamp with time zone. The timestamp with time zone data type, which extends the timestamp data type, includes a time zone displacement. In any programming language, converting one data type to another is a common requirement. PLSQL can handle such conversions with scalar data types. Data type conversions can be of two types: implicit conversions. Place SQL attempts to convert data types dynamically if they are mixed in a statement. In this example, the sal_hike variable is of the varchar2 type. When calculating the total salary, PLSQL first converts sal_hike to number, and then performs the operation. The result is of the number type. PLSQL variables are usually declared to hold and manipulate the data stored in a database. When you declare PLSQL variables to hold column values, you must ensure that the variable is of the correct data type and precision. If it is not, a PLSQL error occurs during execution. If you have to design large subprograms, this can be time-consuming and error-prone. Declare variables to store the last name of an employee. The v_emp_l name variable is defined to be of the same data type as the last _name column in the employees table. The %type attribute provides the data type of a database column. Declare variables to store the balance of a bank account, as well as the minimum balance, which is 1,000. The v_min_balance variable is defined to be of the same data type as the v_balance variable. The %type attribute provides the data type of a variable. With PLSQL, you can compare variables in both SQL and procedural statements. These comparisons, called Boolean expressions, consist of simple or complex expressions that are separated by relational operators. In a SQL statement, you can use Boolean expressions to specify the rows in a table that are affected by the statement. In a procedural statement, Boolean expressions are the basis for conditional control. Null stands for a missing, an inapplicable, or an unknown value. Large objects, LOBs, are meant to store a large amount of data. A database column can be of the LOB category, with the LOB category of data types, blob, clob, and so on. You can store blocks of unstructured data, such as text, graphic images, video clips, and sound waveforms, of up to 128 terabytes depending on the database block size. LOB data types allow efficient, random, piecewise access to data and can be attributes of an object type. As mentioned previously, a scalar data type holds a single value and has no internal components. Composite data types, called PLSQL records and PLSQL collections, have internal components that you can treat as individual variables. In a PLSQL record, the internal components can be of different data types and are called fields. You access each field with this syntax: record_name, field_name. A record variable can hold a table row or some columns from a table row. Each record field corresponds to a table column. In a PLSQL collection, the internal components are always of the same data type and are called elements. You access each element by its unique subscript. Lists and arrays are classic examples of collections. There are three types of PLSQL collections: associative arrays, nested tables, and VARAY types. Host variables. Uses of bind variables. Bind variables are created in the application environment and not in the declare section of a PLSQL block. Therefore, bind variables are accessible even after the block is executed and can be accessed by other PLSQL blocks. These variables can be passed as runtime values into or out of PLSQL subprograms. The first PLSQL block in the slide creates and uses the bind variable b_result. The output resulting from the print command is shown below the code in the slide. As stated previously, after you create a bind variable, you can reference that variable in any other SQL statement or PLSQL program. Use the set outOPRINT on command to automatically display the bind variables that are used in a successful PLSQL block.